Your AI lies confidently with citations about things that never happened. February 2024, Air Canada chatbot invented a brilliant fair refund policy that never existed. And because of that, company went to court and pay fines. And the final verdict was the company is responsible for whatever AI is saying, right? So why does it do that? Why the smartest model on the earth confidently lie about things, right? So it's not intentional, it's a structural. We will walk through the structure of it, and then it will be very clear why your AI lie. Welcome to the Agentic System Design Chapter 4. So in last episode, we have talked about thinking, right? So we have a model which was like knowing everything, and then we also enable it to think hard. But the question we stopped there was, it's thinking is not knowing. For example, if model need to work on something of your personal information or your company's data, no matter how hard it think, no matter you use COT or reasoning, it's basically useless for your own company information or something which is behind your SSO and not available on internet, right? So let's talk about that how we can solve that problem. So first, three things which LLM doesn't know, right? So first thing is your data. So LLM is trained on a lot of public data. It is basically trained on everything available there, but still your data, which is like secured to you behind your SSO, is not something LLM knows. What's your documents, what's your product look like? Okay. Next thing is today's data. So LLM was trained, and then at some point its knowledge was cut off. Like it was, for example, trained 1 week back or 1 month back or 6 months back, and after that it like running into the system, right? So basically it's not having a information or the latest information what is happening right now. So that's the second thing we should be aware about. Third thing is specific thing. So LLM was very good. They trained on every data, but it's mostly a generalist. So if you ask very detailed about any specific problem, and specifically if it is related to your product or your area, this is where LLM will lag. Okay. So we talk about, like, we know there are three problems with this LLM right now. So how to solve it, right? So solution is very simple. Hand it the book, which is like a very simple solution, which means before it asking, you hands your book which is like very relevant to your data, or for example whatever data you want LLM to know, you hand over the data and then ask LLM to do something, and then it will be really working good, right? So this is a very simple techniques where you provide the data you want LLM to work on, and there is a fancy name for it which is called retrieval-augmented generation, also called RAG. And this is very important. You heard in every job description right now that RAG pipelines or RAG, you need to know RAG. So this is like just a fancy name. Simple thing is, it is a way we need to provide data to LLM simply. So what RAG is the whole pattern just in one picture, simple. Okay, so what is happening here right now, RAG is, as I told you, RAG is a system which way you provide your custom information, custom data to LLM before asking anything, right? So it is having basically two parts. One is like your knowledge store. So which means like first you need to index your data or you store your data, which means like your company's doc, wiki, or like anything into some store, right? So we have to chunk it, we have to store it. And the next part is retrieval of it, right? So how this thing work is, so when we ask like what is like X work, how the X work, for example, it's a query. So it goes and ask like your vector database. Okay, one more thing, just a quick explanation here. You heard about a lot about this vector database. So in a simple explanation, vector is nothing but a digital fingerprint. It's like a numerical number. Whenever you say any token, right, it's converted into a numerical number which is called like vector, and it is important all LLMs work on it. And what is like vector database? So vector database is just like a search engine type of thing. So if you see like normal database like SQL or like DynamoDB or NoSQL, it is very deterministic. You say like select star from this where certain. So it's like if it find the answer, it will return you, otherwise it will not return you, right? But vector database work differently. It is not deterministic. It is basically find X similar things to my query. So this is basically important when you are implementing this search type of functionality. So even if you didn't find the exact match, it will return you the top 5, top 3, whatever you are saying, most similar things to your query. So that's called a vector database. We have like a separate lecture in our engineering sections where I will clearly explain how to use it, what is the algorithm behind it. That will be like more in-depth part of it. But here for simple terms, when we ask something to LLM that how does it work, what happening is like we have to convert it into the vector, which is like in some digital fingerprint. Then we have to make a query, and we will find out the X top things which is similar to what your query looks like, and then we will basically pack it into the relevant context and put it with the query, with the prompt. So when it goes to the LLM has the information, a concise information, not all the informations about your prompts, and then based on that LLM will generate the your answers, and it will be like pretty accurate. So this is like a simple RAG system or RAG workflow. And one more short answer, like what RAG pipeline is. RAG pipeline is basically making this thing automated, where your document is changing, so it's updating your database and doing everything together. It is a very good topic. We will discuss more further about it in our engineering section in depth. But here, I think for a high level concept point of view, this is a very good explanation for till now. Yeah, so that's it. That's the RAG is. So it sounds like so fancy, but simply it's a system which will query your hold your knowledge, query it, and whenever you are trying to connect with the LLMs, it will basically attach some relevant informations, or which also known as context, with the LLM prompts, and that's way your response is like more accurate. That's all. Okay. So next thing is 3 jobs you need to do it well when you are building RAG. 3 things is very important there, right? So first thing is chunks and embed. So as I said, like in the first part, you need to store your knowledge, because until unless you are not storing your knowledge, how will you reply? So how we basically store the knowledge, we break it into the chunks. And what the chunks means, which means like basically if you have like big sentences or like paragraphs, we are breaking into the smaller parts. That's relevant. But here is the trick: if you break it so small, then maybe then it will not be like that relevant. It is not having the full information. At the same time, if you break it too large, then most of it will be a noise. And if you are sending so much noise to LLM as a context, there will be a significant drop in accuracy. So trick here is how to break it at a very good like size, or a very good point where it's not very small, and as well as it is not very big, so that it's contain noise. So that's the trickiest part, which as an engineer we need to do, right? Next thing is retrieval of right chunks. So this is like also very important. If you break it, but when you are searching it, you are not getting the right chunk, right? You are just getting some irrelevant information, and if you attach that with the query, it will be like disaster. Rather than it's better to basically not attach anything than attach like a wrong information, which means like you are guiding LLM to produce the wrong output, which is like way worse than attaching basically nothing, right? Next thing is inject as a context. So this is also one of the part where now you retrieve the information, you have to inject it with the context in a prompt. So if you see, first 2 parties very much similar to the search engine. We used to implement this search like Elasticsearch and different things from long time. The only thing extra here is the context injection. So that is important. So you query things, you got the top things. Now how will you inject it? So these are the top 3 high level jobs which we need to do inside a RAG. How will we do it? It's an entirely different topic to cover, but this is like a top 3 things you should remember about. Okay. Next, the real constraint before moving forward, the context window is the bottleneck. So one of the simple things which people say, like just put everything into your prompt, right? So no, the problem is we have a limited context. Even right now the models, they are like 1 million tokens, or like they're like that. But still, if you start putting everything with the query, right, soon the context will blow up and it will not reply. You will not get much benefit out of it. So basically there are 2 problems if you just start bloating your context, right? First thing is obviously the cost. You are paying LLM on per token basis. If you're putting more information there, which means that you are consuming more token, which means you have to pay more money. That's the first cost. And second, which is another cost, is the accuracy. If you're just bloating LLM with random information, as I talked to you, right, which contain most of the noise, the output from LLM will be very generic, or maybe the accuracy will drop significantly. So there is 2 problem. So that's why when we are injecting anything into the context, we have to be very crisp, and the context should be very on the point. We should not just put like random things and put our whole doc to the LLM. That will be like disaster. So we need to keep that into the mind. That's the trickiest part. Okay. So RAG isn't free. So if you see in my last lectures, I've always talked about the cost, because AI is very costly and it is going to be more costly. So as an engineer, we should be very much frugal about things. So RAG is not free. So it's not like you just put it and now with every query you start putting this information with the prompt. No. So let's discuss like when to use it and when not to use it, which is important part, right? So you need to use RAG when answer required your specific data, right? For example, you build a chatbot which need to query your policy about product, right? Like someone asks that, okay, what is the refund policy? Then obviously you need to give your information. If it give the generic refund policy, it will be a disaster. You might go into the court. So yeah, that's the important part. Or sometimes the freshness matter. Like you want to put something into LLM they are not trained on, or like you want some citations. So especially like in a short summary, if you need some custom information, some information which is not available on internet, which is very, very specific to you, so definitely you use RAG. Now the next part, when not to use RAG, which is like if you are doing some logical things like pure math, logic, planning, or something like small classification, sampling, which doesn't require any specific knowledge about your company's data or your own data, please don't skip RAG because that's costly. And again, it's not about just cost of the RAG, it's also the cost of the accuracy, cost of the tokens. So it's like it's not about if you're adding it, nothing happens. So if you're adding it, it's also doing a wrong and negative impact. So the cost is in every terms. It's not about the money only, it's also about the accuracy, right? So we have to be very much careful up here, right? So next thing is 5-way RAG breaks. So this is a very fancy concept, but there is an also bottleneck when you are designing RAG. So what the 5 bottleneck which can go wrong? First of all, like I already told before, the batch chunking. So if you are when you are embedding your doc, how you are chunking it, how you are cutting it, it's very important. Too short, it's lossless, meaning too long, it's basically content noise. So that is one of the key area we have to think as an engineer. Next thing is irrelevant retrieval. So this is important. Your search, your index should be very efficient. Otherwise, if you just put some wrong information with your context, it will be like disaster. It is worse than putting nothing, right? So next thing is stale index. So what happening is like your docs change, your policy. For example, most important, if I talk about this Air Canada things, right? Or especially if you're building a customer facing chatbot which rely on your policy, or you're building something in legal where things are important, then stake is very high. So docs change, policy change. So you have to make sure that your index is not stale. So how to solve it? There are engineering solutions. We have to build pipeline that anytime anything is changing, we have to refresh our index. So that is like in part where we need to be little careful about. Okay. Next thing is ignored context. So yeah, this is like most of the funny part. So even if you put right context, everything into your prompt, your LLM will ignore it. Why? Because they are designed that way, right? They're designed to have their own logic, have their own context. So fixing is very simple. You need to specifically mention into your prompt that please use data from the context. Like this is a very small thing but people miss. So sometimes what happening is like we build a fancy pipelines, everything is fine, but still LLM output is not that good because LLM is not even like taking your context, it's basically ignoring it. So we have to make sure these are like catches. As an engineer, we should know like where things can go wrong. So this is like one of the very small but funny like incidents, right? Next thing is constant blowout. So this is like something which is very important. So when you are putting context into your prompt, right? So we are always greed toward put more things so that LLM will give me like more output customized to myself. But as an engineer, we have to be very careful because as you are putting more things, as I talked before, we are costing more money and as well as we are reducing the model accuracy. So we have to be very crisp that, okay, what we are putting there. So yeah, so the one example like I told in initial that Air Canada one. So what happening is their chatbot basically someone asked like they missed the flight refund for vibrant issue and they said yes, this is a policy, and they just said okay, you will get a refund. Maybe like model was trained to be morely supportive in that situations, and what happening is like Air Canada like didn't refund it. They went to court and eventually they have to pay the price, but it was a lesson. The court say whatever your chatbot is saying, you are responsible for it. So this is a very important thing. This is the biggest problem I think why AI cannot replace human, because the accountability part, who is the responsible part? You cannot fire AI, you cannot just blame it. Someone need to be responsible, right? So here the engineers who is designing it or the company who is owning it is responsible. So that's why it become very much our responsibility to make sure that LLM is doing right, because if it goes wrong, it's on us. So we have to be very careful, right? So if you see RAG is a subsystem, which means like we have to so it's not built inside the agent, so we have to build it outside. So and it will also work as to like together with the model thing. It's not like it's a one-time thing, right? So for example, we have to put evaluation like what your retrieval quality is. We have to also make sure it is going correct, and also the system, we have to make sure our system of record is fine, and whatever input we are putting to the like your rack, make sure that input is like correct. We have to sanitize the input. We should not like just rely on as it is. There might be a prompt injections things there. And next, talk about the AI digest, which we will build in our engineering sections. We will put this RAG example, and I will explain you like how we will use it, how we are thinking about it, right? One thing before we go, like you might see with this AI coming, with this RAG coming, we are seeing an entirely different set of work which is coming to our engineers, right? So it is different than traditional work, and it is very interesting engineering problems. So if you are smart enough, you can see like whether AI, like where the AI is coming. It is generating new work for us, and maybe this is the future. And it's like a new different set of engineering. It's still day one for it, but we are seeing a different set of engineering and different set of problems coming. So yeah, that's a kind of a positive symbol where we are heading, right? So let's move. So the next questions. Now you know that your LLM knows things, but still it can't do anything, right? So if you see if you see the progression we have building, your LLM has a lot of knowledge, and then basically your LLM also think good, and then right now LLM also has information about your own, right? But still it can't do. If it can't do, it is just like a fancy search engine, right? So next episode we'll talk about how we will make LLM to actually do something, right? For example, it's debug your code, or but it cannot like put it on your, it cannot read your tickets, or it cannot put your there. So it has no meaning, right? So we will talk about this, how we will actually make LLM do something. So that's a topic for next episode. See you there. Till then, bye bye.